What's new on this? Not much. Infinite pre-calculus. So on number 1, it says find the component form of the resultant vector. Component form is basically how number 1 is written, just with the x and the y coordinate. That's how we've written most of our vectors. So like the 20, negative 21, that's in component form. But on number 1, it says find negative 3 times vector u. So number 1's kind of easy. All you have to do is multiply the components by negative 3. So that would be negative 63. And notice this worksheet is using different notation. It's using, instead of parentheses, it is using these arrow things. I don't know what they're called. These things. Yeah, I think our book is a little bit outdated in that sense. Because when you use parentheses, that's supposed to be like a point on the graph. Like number 2, 0, negative 4, that's a point on the graph. So on number 2, I think there's an odd like this. On number 2, you would need to find the vector PQ first. How do you find vector PQ? Well, so the x component, we're going from 0 to negative 1. So how far are we moving in the x direction? Negative 1. And on the y component, we're going from negative 4 to 9. How far are we moving in the y direction? 13. If you're not sure, you just do the second y component minus the first y component. So it's like 9 minus negative 4. That tells you how far it's moving. It'd be positive 13. But then you have to, of course, multiply by 8. It says down below. Vector PQ times 8. Okay, number 3. 3 is super easy as well because we just have to add the two vectors together, which is the same as adding the x components and the y components. So it'd be 14, 11. I'm kind of planning on us, I'm assuming we'll be gone tomorrow. And the test will be like Tuesday. That's kind of the plan. What are you going to do if we're not?
You're not telling me.
Oh, you actually have a plan?
We're gonna walk our dog.
We can also go somewhere.
For like 8 hours of school time?
It snows a bunch. So I'll go to the dam.
It's supposed to be like
down like a
freezing
giant hill.
tomorrow.
It's not the point.
Yeah. I'm just saying. Because like that hill is like.
Dude,
I just
really
wanted to go for
clear.
like 2 hours and I was like, oh, okay.
Although, to be
And
fair,
then we
if you
take
would,
the
if
same
you did
route
probably
that
do that,
she
you'd probably die.
And we
Because
get
the
there
other
like
divot,
in 30
it goes
minutes and she's
straight up.
like, I love
Dude.
you guys.
So if you fell that divot, you'd probably like.
Were you exaggerating or
Did you
just
see the
going
video of
super
Neon's
slow?
cramp?
Yes.
So slow.
I mean, like
She's
down
on her
to
phone
that,
and
that's like 40 feet
No,
drop.
I was thinking,
Then
like,
it-
no,
then you
I
did
don't
it
vlog
up
on my
straight.
phone. I just
Like,
Yes,
you probably
you
like
do.
that.
no, she's
I've
not.
seen
To be
her.
fair,
I've
I
got
did it
crippled
once.
dogs.
I've seen her like,
So.
you know, and she
Obviously, you
doesn't
heard
know
her.
that I'm there, but like I get
No,
her
I
on
rolled off the
Why
thing.
she
I
was
was-
I mean, there's.
Oh yeah.
It's like,
You did.
I rolled off the thing
Okay,
before I
but
got
also
bottom
we're
and I
not
fell in the
talking
thing
about
and I hit
that.
my
My
back
dogs are
like
slow,
really
their
hard.
legs are
I bet you
broken.
did.
Hope has 2 torn ACLs.
I did.
Oh, that confused me. Your dog's name is Hope.
That was a rip?
So yeah, they're slow at walking. I'm sorry.
How does a dog tear its ACL? That doesn't make sense. Okay. Anyways, number 5.
It's a struggle.
We have. You tear an ACL by like trying to turn sharply when you're playing basketball or something.
Yeah.
How does a dog? I've never heard of a dog.
Never seen her play basketball.
Okay, so on number 5, we have to multiply vector f by 4, vector v by 6, and then subtract them. So vector f times 4 is 48. I'll write this down. And vector v times 6 is 1224. And that creates vector 48 minus 12 is 36. 8 minus 24 is negative 16.
Let's go. This person's actually not
Did it tear its ACL because it just like is falling apart?
My dog?
Yeah,
It's falling apart. She's just old. She runs a lot.
does she?
Yeah.
Still, it's, I don't know. Anyway,
You're doing all the work. You're spade. Good job.
okay, on number 7 it says unit vector in the direction of AB. So, yeah, kind of like we were doing on number 2.
So you're not gonna do it with us?
So on number 8, just a second. On number 8 says the vector opposite of PQ. What do you guys think that means? Well, you just, it's not, no, it's not perpendicular. It's not that hard. It's, if you had like vector, let's say 10, negative 6, it'd be negative 10, positive 6, yeah. So you just switch the, you just switch the signs. It's the opposite, x component, y component. Number 7, something, unit vector. I don't know what they mean by unit vector, so, but it doesn't matter. We'll just do the normal vector from A to B. So from A to B, we're going from 4 to negative 6. So that would be dropping 10. And for the y values, we're going from 0 to 10. So that would be increasing by 10. So let's go with that. Okay, number 9. So this is kind of new-ish, some of it. The direction part is something that's a little bit new. We've started with the direction and found the component vector, but we haven't gone from the component vector back to the direction. So that's a little bit new. Okay, so on number 9, we're supposed to find the magnitude and direction of the vector. So first, I'm going to find the vector in component form because it says add those two vectors together. So 6 plus negative 3 is 3. And negative 10 plus 11 is 1. Okay. Do you guys remember how we found the magnitude for a vector? This part you should know.
Add square root, and then you add the oh. No.
Okay, 3 squared, 1 squared, and
See,
squared.
that's exactly what I said.
Well, kind of, yeah. Okay, so that's 9 plus 1 is 10, so
Oh, yeah.
the magnitude is square root of 10. Magnitude just means the length of the vector, remember? Okay, what is the direction though? So a 3-1 vector looks like this. It's going 3 in the x direction, 1 in the y direction. So the direction would basically be this angle right here. How could we find that angle? Yes, good. SOHCAHTOA stuff. So this makes a little right triangle. So relative to this angle, we have opposite and adjacent. That is tangent. So tangent of the angle equals opposite over adjacent. So how did we solve for the angle? Tangent inverse. 1/3. I have the answer sheet somewhere.
Bro, what are you talking about?
They put 18.43. I guess it doesn't tell us where to end it, does it? Okay, 18.4, that's fine. So those two are the answers.
So they all have two answers?
Yeah,
Or
bro.
Make something better.
I'll just make them worth like 1 point each. Okay, number 11. So we have to multiply by -5. So that would be -60, -80. Kind of a large dude. All right, how are we gonna find the magnitude?
60 squared.
Yeah, now, you could say it's -60 squared, but the negative doesn't matter, because when you square negative, it's positive, so we could just do this. So it comes out nicely. Okay, so -60, -80, we got to kind of think about this a little bit. What direction would that be going in? -60, -80. -60, -80. It'd be like going down here. So finding this angle right here is not exactly the answer. It would actually be 180 degrees plus this angle. You guys follow that? So we really didn't do this part on the homework, but it is going to be tangent again. That's kind of happen every time, because these are the opposite and adjacent like every time. The x component's always the adjacent, the y component's always like the opposite. So tangent of the angle, maybe I should use theta instead of equals opposite over adjacent. So we need to do tangent inverse of that. You could reduce to like 8/6 or 4/3. You don't have to, but what's that come out to? Okay, 53.1, which is not quite the answer. Because what did I say? That's just this angle right here, but the direction is all the way from here to here. So we need to do 180 plus 53.1. So it's 233. 180 plus 53.1. Number one, or the last problem, we didn't have to do that because it was just in the first quadrant. It was like right there. So that angle was the answer. But if it's over here in the third quadrant, yeah, it's 233.1. So that's one of the answers. Where to put the other ones? Way up here, 100.
How do you do 10?
So you need to start by finding vector tx and then make it negative. So tx is going from 10 to 0, so what would the x component be? Negative 10. From -4 to -1, +3. But then the negative down below when it says negative vector tx, yeah, you just switch both of those. And then you find vector yz and subtract that from vector tx. And then you still have to do the magnitude and the direction. Kind of a lot of work. Okay. 13. The odds are easier than the evens. That's funny. All right. So 13, we do -3 times vector a, so that'd be 936. And then minus 7 times vector b, so minus 2863. And that gives us 9 minus 28, negative 19. 36 minus 63, is that negative 27? Okay, well, that's the vector, but we need the magnitude. So we have to do 19 squared plus 27 squared. This one does not come out pretty. Doesn't really simplify. Anyway, that's the magnitude. Okay, well, okay, where is vector negative 19, negative 27? Well, negative 19 is going, tells us it's going this way. Negative 27 is going this way. So actually it's kind of like the last problem. The vector's in the third quadrant. So we're going to have to do tangent inverse, but then we're going to have to do 180 degrees plus this angle to find the direction. So we need to do tangent inverse opposite over adjacent. Anybody plug that in already? Is it 54.9? 54.9? Would be this angle, so the whole thing from there to there would be 180 plus 54.9. 230.
I just forgot that you had to add the 100.
How many of the evens do you do that for? Is it just the ones that like are negative for it?
Depends on what quadrant they're in. So if it's like on 10, it's actually a fourth quadrant angle.
Is it a negative? Or did I do it wrong?
Kind of. So what, tell me what you got.
I got negative 57.3. I don't think that's right. Oh, okay.
Well, it's a little bit off.
It is.
That's a little bit off too.
I got 41.6.
Okay, you two got it right.
Let's go.
But it's not negative though. So what did you, tell me what you got for your component form of your vector on 10.
Might be 11, negative 14.
Okay, so did you guys not get 11 negative 14?
Correct.
There's a lot of steps before you get to the direction.
Wait,
part.
isn't it negative 14?
It must be because they got the answer.
Yeah.
It was what?
Wait.
They got 11 and negative 14.
11, negative 14.
I mean, no, I mean, like, how would it work? Did you make those negative? That's good.
Yeah. So then they did, well, you guys all did this part, right? I think you just got this part on 11 negative 14.
Yeah.
But then you did tangent inverse of that. Negative 14 elevenths, basically. And tell me what it was again. Negative.
51.13.
Okay, that's not quite the answer. So when we did direction, I don't know if you guys remember this chapter. It starts here and goes this way, right? So if it's negative 51.8, that basically means it's 51.8 degrees short of 360.
Is it 270 plus?
Yeah, so you do 360 minus that. And that'll give you this angle right here, which is the direction.
That makes sense.
We did that, something very similar to this on a chapter long ago. Probably about 2 or 3. What?
Oh, is it Willis?
The Willis is here.
Oh, what?
Should I get her helping now? Did you just skip the English test? Is that what?
Oh, yeah.
Liz,
No.
are you doing 15 with us?
Oh, yeah, I kind of forgot about 15.
What
Wait, is this the answer sheet? Nice try, Willow. Nice try.
Get 15?
Let me read it first, see if I remember it.
It's short.
Draw a vector diagram to find the resultant of each pair of vectors using the triangle method, then state the magnitude and direction. And that's kind of the same thing as what we've been doing.
But it's just too.
Yeah, I'm gonna do it. It's not that much work. Okay. Vector M is negative 7, 1. So what would negative 7, 1 look like?
Back 7. 10 forward.
Yeah, it's mostly left 7 and up 1, so it's kind of like that.
Do you have to draw this too?
We probably shouldn't draw very big. Yeah, the drawing is part of the answer. And then vector N is 12, negative 16. What would that look like? Well, it'd be 12 to the right and 16 down. So they started it at the same spot, 12 to the right and 16 down. It'd be more down than up, and it's kind of long compared to M. Oops. No, I did that wrong. So they just started it right here at the end of M. More down than up, or more down than right. Kind of long. Actually, it's even longer than that. Okay, and then the resultant vector that you get from adding those two together is basically this vector right here. This is vector M plus vector N. We'll see how accurate my picture was. You can find the vector by just adding the components, right? So negative 7 plus 12 is 5. I don't know if they did it this way. So it is supposed to go to the right a little bit. And then 1 plus negative 16 is negative 15. So probably should have done, that's, picture's kind of close. Not that big deal. But anyway, we need to find the magnitude and direction just like all the rest. So the magnitude is 5 squared plus 15 squared, square root. What does that come up to? They didn't even put the square root version, they only put the decimal version.
But 15.
They put 15.8. Okay. Yeah. Whatever. Okay. And then the direction. So what quadrant is this vector in? 4. So it'll be kind of like the number 10 that we just talked about. It'll give you guys like a negative angle, which is like telling you how far it is from there to there. So what we're gonna do, okay, let's just figure out what it is. Kind of feel like I should redraw my picture. So the vector looks kind of like that. It's 5 to the right and 15 down. So to find this angle, we need to do tangent inverse. Willow, you kind of missed this part. Tangent inverse of opposite over adjacent. And they should give us a negative angle. negative 71.6. Okay, that's not what we're gonna put though. Our direction starts from 0 and goes this way, so we really need this angle. So how do we find the angle from here to here? Well, basically this is 71.6 degrees short of full 360. So we need to do 360 minus 71.6.
289.
288.4.